Hi everyone, this is Cheryl and welcome to Cloud Native London, May 2022. Today we're live streaming across YouTube and Twitch, and we're also going to be on Rambly. So wherever you're joining us, it is fantastic to have you here. Today we have just one speaker who's going to be talking to us about next-gen observability using open source monitoring. And let's kick off. So welcome. If you haven't been to Cloud Native London before, we are a strong, open, diverse developer community dedicated to the cloud native platform and technologies in London, and of course, virtually everywhere in the world right now. My name's Cheryl. You can find me on Twitter at @Cheryl. I hang around the cloud native community. And Aloke is going to be joining us as our speaker for this evening, talking about next-gen observability. We're going to wrap up at 7:45 UK time. Unfortunately, we were planning to have two speakers for this evening, but the first speaker had to drop out due to a personal reason. So Geordie will have you back on a future meetup. Right, let's find out a little bit about you. So we're going to go and do a little bit of live polling using this service called Poll Everywhere. If you have your phone or your laptop on you, just go to this link, bocheryl.com/p. Don't need to download anything, it's just in your browser. And I'm going to ask you 3 questions about you, and then 1 question about how you use cloud native. And you're going to see this kind of screen where you can put your screen name in, or you can just skip it. And we're going to just check out a little bit about the people who are joining the meetup tonight. So first question, is this your first time at Cloud Native London? You should see 2 buttons on your screen, yes and no. I see some people have already started answering, said no. So I'm going to give you sort of about half a minute to just figure it out. If you forgot that link before, the bocheryl.com link, you can also use this slightly longer one up here. Okay. I can't tell if people are actually answering no and only no at the moment. Oh, there we go. Someone said it was their first time. Sweet. So again, go to that link. We'll go to this link up the top here, and just you should see 2 questions, 2 answers even. If this is your first time at Cloud Native London, then hit yes. If this is not your first time, then hit no. Okay, I'm going to keep going. Let's see. Okay, where are you now in the world? So you should see a map of the world. Just press wherever you are at the moment, and hopefully we'll see a few people pop up. Okay, a couple of people hanging out in the UK. Aloke just told me that he's dialing in from Colorado.
That's right.
Oh, people feeling shy tonight. Oh, okay, we've got another UK person. Okay, let's, here we go. I don't know if Aloke, that's you. Somebody else.
That might be me.
We're going to keep moving. We're going to move on. So what is your job title? Just pick whatever's closest to what you do. So the options here are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or other. Well, some architects, some others as well, backend developer. If you are someone who's put in other, then you should introduce yourself. Like, what do you do? Oh, more architects pulling ahead. This is fun because usually we see a few SRE and DevOps engineers. Not sure if we're seeing people tonight. Alrighty, feels like the answers have slowed down. So let's just keep going. All right, this question was submitted by Aloke. So what telemetry do you use to monitor and manage your cloud native applications? So your options here: metrics, logs, traces, and a combination of them. So Aloke, like, what were you thinking when you submitted this question?
Yes, this is always an interesting one. I've been at a few DevOps meetings recently in person. What I've noticed is, historically it's logs and traces, and then people will use metrics later. So I'm trying to see how many people are log centric or trace centric. And I'm trying to see when the combination is also interesting. Unfortunately, I couldn't have multiple. Which combinations do they use? Do they use logs with traces, logs with metrics, logs with metrics and traces? There's a number of different things. And this will lead into some interesting discussions. So I've seen logs. Interestingly, no one is using traces, which is typically what APM tools are used for. And I'm surprised there's nothing on metrics. I'm not sure we have a statistically large sample yet.
I'm guessing that people have put in combination, but David.
Yeah, that's true. So maybe we should tell people multiple options are allowed. So select, if you're using metrics and logs and combination, select all three. I should have said that. So it's not a single choice. You can have multiple choices here, more than one. So go ahead if you can update that.
David, what's your thoughts on this?
Generally, I mean, we see a combination of logs. Obviously, with our side, we obviously try and pull data in from cloud service providers and the actual platforms as well. It might be a deployment of Prometheus in there, perhaps, on those cloud native workloads. Yeah, there's a real mixture out there. There was a really good session, was it last year that we did on the Cloud Native London meetup on this topic, if I remember right. We could pull them back and see if that's evolved in any way as well, because I remember they were pulling in a combination of all of them in order to enhance, yeah. And
if you were to say, David, there was a kind of a distribution, you would say the combinations outweigh just pure metrics, pure logs, pure traces. Anything, if you were to order them based on what you saw? I'm curious also, 1 year later, what has happened?
I think I don't think it'd be for me to say, really. I'd have to defer to someone who's deploying out to scale.
What do you think?
Yeah, because insisting we have a product that is pure metrics in terms of, it is Prometheus centric. And what we see is that, very rarely are monitor customers just doing metrics. They will have either logs or traces or both. And often it'll be the dev teams that have the traces and the ops teams will do the log aggregation. And then both will use the metrics to augment. And then you'll often then turn alert feeds to augment the logs as well. So it's always a combination of the three, and then different teams or different functions within a DevOps team will look at things from a different angle.
That makes a lot of sense. That reinforces some of the things I heard in the last 2 DevOps meetups I went in the last 3 weeks. So, Tom, what you just said, Dev usually relies heavily on traces, and Ops relies on metrics, logs, as well as traces.
I would be surprised. Yeah, I was interested, Aloke, that you said not so many people using traces. Yeah, like Tom, do you think?
It depends. On the ops teams, and I don't want to presuppose everything or skew the audience. In the ops teams, I've seen a camp and I can talk about a specific customers that we have who disavows using traces because it takes too much time to dig into it and they don't know which trace to look at. That's a typical problem, especially if they have a large enough microservices application, too many things, which ones do I look, unless the dev team said you should be looking at those 2 traces and nothing else. There's a lot to choose from.
But in a previous life as an actual delivery architect, I've seen where I had a dev team who were using traces who identified a bottleneck in their application, where all they could do was point to a component in OpenShift, it was in this case, but they couldn't see what was wrong. And then you had to actually delve into the platform metrics to be able to figure out what was going on. And it turns out, it was quite a deep technical issue. But, so you needed the combination of, the traces, the app team knew that they had a slow performing application, or they were getting random 503s. They could pinpoint to where it was roughly. They then had to pass over to the platform team, who then had to delve into effectively down into the system traces on the actual infrastructure nodes on the OpenShift cluster to identify that what it turned out to be was TCP pool starvation in the underlying Linux OS. And it's like, you're never going to get that from a trace, but you need a combination of both to solve issues.
I'm glad you brought that up, because I'm going to talk about that, because actually, customers mentioning this. So I think that is still pertinent today.
Mm-hmm.
By the way, logs just reduced from 20 to 17%. What happened?
Somebody else voted for combination. That's what happened.
Yes.
Sweet. Thank you. Yeah, thank you for voting as well, for everyone who's participating in this. I think that's generated some interesting conversation. I have a feeling I've skipped a slide, so I'm going to go back a moment. Yes, I did manage to slip this slide. Yeah, skip this slide. So let me just say thank you to our sponsors for this evening, who, as always, support this meetup and this event and keep us going. So David, you're going to go first.
Okay, yeah. So Prisma Cloud, part of Palo Alto Networks, that's what I'm here to represent as a sponsor today. If you haven't heard of us, then we're essentially the cloud division, cloud native division of Palo Alto Networks. All of our security is orientated around the applications that you manage, run, host, develop, build, ship, run, and so on. And so that includes, of course, Kubernetes applications. Mentioned Tom OpenShift, for example, or any other cloud native deployment in public cloud, whether it be microservices deployments or such, and public cloud posture and many other use cases as well. I'd say the biggest thing that we're principally helping customers with at the moment is enabling more of that security to be implemented through the parts of the lifecycle. For example, in the context of Kubernetes, we might be looking at things like Kubernetes app YAML files to ensure they're configured in accordance with best practices, or we'll be looking, of course, at, as usual, at vulnerable packages throughout the lifecycle as well. Big focus on pipelines overall. Software composition analysis is a relatively new space for us as well, as we get into more places that we can look at code and look at libraries and so on throughout the life cycle. So yeah, if you want to know a bit more, then feel free to reach out to me, David J. McLean. That's on Twitter and LinkedIn, and I can help you understand a bit more about how we help customers with cloud native workloads.
Wonderful. Thank you so much for introducing Prisma Cloud Palo Alto Networks. I'm going to read out a little blurb on behalf of Circle CI, since they couldn't send someone this evening. The world's best software teams use Circle CI to deliver quality code with confidence. As the largest CI/CD platform, Circle CI empowers engineers to seamlessly take ideas to execution at scale. Every feature of our platform is built to fine-tune the entire development process from start to finish. And over to you, Tom.
Thanks, Cheryl. So I'm Tom Llewellyn. I'm here to represent Sysdig. And Sysdig, we're in a similar space to Prisma, and we have a slightly different approach. And I guess the key thing being, we're built on an open source foundation. So we are the founders of the Falco project, which is a CNCF hosted project. Sysdig command line is open source, and we build on projects like Prometheus, Cloud Custodian, OPA, and so on to build an enterprise grade platform. And then what we deliver with that, so we have a visibility product called Sysdig Monitor, which is essentially scale up Prometheus, delivered on a SaaS platform. And then Sysdig Secure, which has a very strong runtime security capability built on top of Falco. So this is a runtime rules engine delivered using custom policy written in YAML and so on. And then from there, we build outwards. So we have vulnerability management. We've recently launched a new capability we call Risk Spotlight, where we can actually trace vulnerability exposure at runtime as well. So because we're aware of what's running in your containers, we can tell you which of the vulnerabilities in the container image are actually being exposed at runtime and so on. And we're building actually in a similar direction to Prisma as well, in terms of going towards infrastructure as code scans, compliance and so on. So with similar space, slightly different approach. And if you'd like to learn more about Sysdig, please visit us at sysdig.com. You can sign up for a free trial there. If you get to complete your free trial, then you can also apply for a free t-shirt with the Kraken on the front, which always proved to be quite popular amongst the community. And any questions, then please reach out to me. You'll find me, I'm Tom Llewellyn. I'm on most platforms. So
nice. Thank you so much, Tom, David. So see, I don't have a blurb to reach out on behalf of Control Plane, but I want to say thank you to all of you, since this is what keeps this meetup running and has kept it running for the last few years. And I have an exciting announcement as well, which is that we are going back to in-person events from next month onwards, from June. We'll be, well, we'll be doing hybrid. So if you're joining us online, then you can still join us online, but hopefully we'll get to see some of you in person as well. So we're going to be hosted by eSynergy at this address in London. Please do come, please bring people along. I'm really excited that we're going to be back in person and having pizza and having beer and doing all the usual meetup things again. So I hope I will see you there. With that, I'm going to stop sharing my screen and hand over to Aloke for our first talk. First and only talk of this evening.
Yes, okay, so let me share my screen. Thanks, Cheryl. Let's make sure I have the right one. Hopefully this is showing up. Can I get a thumbs up?
Yeah, looks
showing
good.
up. Excellent. So thanks again, Cheryl, and to the Cloud Native London meetup for inviting me. It's kind of, I always have fun because I get to be interactive. So my name is Aloke Guha. I'm the co-founder and the CTO for a company called OpsCruise. We are just shy of 4 years old. But we've made a lot of progress, including, I just wanted to tell you, brag, we just got named the cool vendor by Gartner in the observability and monitoring space for cloud natives. So I thought, since it's a cloud native crowd, I want to give a shout out to all of you. So at least you know we are not a totally unknown. So that's great. So today's topic is going to be on what we call observability. Notice I don't use the word monitoring, and that become clear in a minute. And it's going to be actionable observability for cloud native applications. I'm going to jump right in, and I know this will be a tutorial for some of you, those of you who are working cloud native, and clearly for folks like Tom and David who are already in there. And I just want to point out 3 things that we've recognized over the last few years, ever since microservices came into the forefront and became the dominant way of deploying applications. There are 3 things that I always talk and I find out from people: complexity of applications, just the scale and the abstraction between microservices to orchestration like Kubernetes to the infrastructure, whether it's running on-prem or it's on public cloud, etc. And that just basically creates a lot of lack of visibility into what's going on. And so you can imagine, and that's why I use this chart, I've used it for 3 years now, whether it's a problem in the cloud, and I think Tom was giving an example of something that happened on the platform, something happened incorrect in Kubernetes, or of course in the application itself, any microservice is changing. That just creates complexity. And of course, all of you are familiar with the Netflix Death Star. So now do you imagine the Death Star? You may not have quite the Death Star. It's a small star. It's a lot of stuff to look at, complexity and scale. Second thing is dependency. I just talked about the tiering here. But now I have dependencies on shared services. I'm calling a cloud service on the database, whether it's SQL Server, Cassandra running on cloud. I'm using a Lambda or some function as a service, etc. And all of them adds more complexity because those dependencies can affect my application. Probably the third and the most pernicious problem is dynamism. How do you keep up what's going on in this, this hierarchical complex map when you're doing auto scaling? Your dev team essentially changes one application, takes it down, brings up another one, starts adding more things to it. Or, I just added a service. And so all of these transients is probably the nightmare scenario because you can't keep up with the complexity. There's a good news here. And this is why we talk about why open source monitoring is useful. You can get data at every level, whether it's metrics, as you heard, traces, logs, even flows. So it's not the lack of data, not the lack of dashboards. It's basically the ops teams trying to figure out what's going on so they can take action on it. And the historically pre-microservices, there have been a lot of agents and proprietary tracing and etc. And all of that hasn't really helped the situation. So ops lacks the skill, and the question, how can we help them? And that's where we come in, right? So I gave this talk at Observability Summit at KubeCon, 2019, I believe. And this is one of the things we brought about. The fact that we need to understand the dependency and the dynamism across the app Kubernetes infrastructure. We need to understand that when ops works, they understand the role of Kubernetes, what's happening. They understand how much services behind, containers, etc., their role behind the microservices. They are aware of apps. They are aware of issues like shared entities cause a problem, like persistent store. They want to know when they look at anything and they're trying to figure out what's the problem, what is the data going on, what's in inbound, what's the outbound, what resource service they use. And then how is the application supposed to behave? I think we're just talking about, you need to look at this trace because that's where the request comes in and this is what it does. So if I can get this information on dependency, understand how to apply curated knowledge and understand the current state and understand how it's supposed to behave, you get a long ways. So if you think about application workloads, there's infrastructure, there's orchestration, metrics, flows, traces, and logs, all of that. What we want to do is leverage that information. And that's what I'm going to talk about, how we play. And so what we decided that we need to do is really, as you heard in that survey, it's not about just logs, not about traces or metrics, it's everything. There's an old fable, right? If you have basically multiple blind men, each touching each part of the elephant, metrics, logs, traces, but they don't get the whole picture. In similar way, we have to look at metrics, logs, traces, flows, even the configuration Kubernetes to understand. So what we did at OpsCruise was essentially build this smart layer that essentially pulls in, understands the model of the application, understands the dependency, in fact, derives the dependency, and uses it predictably to detect anomalies. So you don't have to worry about thresholds. And then the next thing that we think that has the biggest impact on helping ops teams is automate the causal analysis process, at least reduce the space they're looking at to bring the relevant information to the ops teams rather than the other way around, which is usually what happens today. So you asked, what is open source things that are available out there? And you can see what we build on. So metrics clearly, and you've heard Prometheus, and if you're scaling at Thanos, you're looking at logs, Elastic, of course, you're feeding it through FluentD or FluentBit. Loki has become the other open source standard. Traces, open tracing, Jaeger, OpenZipkin, config, that information is embedded in Kubernetes we want to leverage. Changes, there are still things that are in the works. We can leverage, of course, Kubernetes as well. And then topology, there is no way understanding topology. So one of the things we use is Flow, and I'll tell you how we do that. And Flow also is open source, if you've heard of things like Istio, Linkerd, but also eBPF. So that's what we are building on, all the standards. And our premise is you can't just rely on the 3 golden signals that people have talked about for the longest time. You need all of these to understand the current state. I'll give you an example, and I'm probably not going to dwell on this. This is the fundamental problem that we discussed just before we kicked off. The biggest problem that folks face is when you're digging into it, understanding how do you get to a specific trace. The problem with that is we have a huge cardinality problem. This is pretty well known. So most people we know rely on very small single-digit tracing because they can't keep up with it unless they're looking at it. So they'll miss the problem if you're looking at traces. What we have done is leverage flow like eBPF we do full sampling without looking at specific traces, and we can find out across the services that comprise the application what happens, including looking at the URI. That way we get an aggregate view of changes in latency and errors and so on. So we're not doing tracing and we don't need code instrumentation. What then happens is we can leverage that to dig into what we call trace path, the most common routes being taken. And this is an example of a service path. Let's say these blue and the pink line tells you those are two well-known trace paths that everyone uses. So if you find a problem in flows, we can go down to the trace path that overlay those flows, meaning those containers or services that are in the trace path. And so when we detect it in real time, we can dig into the trace path. And from the trace path, if a trace path is slow, especially the ones that are most critical, we can then dive into and pull in the corresponding traces. This allows us to narrow down into a specific problem very quickly. And so this is an example of leveraging contextual integration across multiple things, flows, metrics, down to traces, but without getting overwhelmed. Fine. I won't cover this, but it gets more involved, but this is one way of solving the fundamental cardinality problem. One of the things we did was, as we said, we are built on open frameworks, right? I mean, we just talked about that. And the reason we did it, for the same reason as you heard others in this call, is because you're future safe. You don't have to worry about anything. Also, those metrics collection, telemetry collection now can last long, well after you do anything specific and any kind of analysis you do on top. So it just gives you the framework and the foundation. The smart weave is understanding that dependency, that structure, the topology of the application. This is something we had to do building on top of that. And this is an example I'll talk about and I'll hopefully show that in the demo. And this has to be real time. We need to be able to stitch together which services are present in the application, how they're talking to each other and connecting, right? Then it becomes interesting. So I know this, I know the structure of the application. I know the dependencies, who's talking to whom in the application. I know how the application services sit on top of Kubernetes and how it depends on the infrastructure. Now, how do I know what is happening? And when do I expect to detect a problem, hopefully, before things really go south, as they say. And so what we've done, one of the key things we've done is leveraged AI, ML in this case, in a way that's probably quite unique. You can't expect ops to figure out and set thresholds or decide metrics on it. A container has over 40, 50 metrics. If we take something known like Kafka, it has over 120. So what our application or our SaaS controller does is, after they know the structure, it actually starts profiling the expected behavior of every service, every container that comprises the application. And it typically takes about 24 hours. And the reason for doing that is it doesn't make any assumption what metrics to look at. It basically takes, in the case of a generic container, over 30 metrics and starts looking at how they change as demands increase, requests increase, and so on and so forth, calls it makes, the resources it uses. So in about 24 hours, you get a sense of what is the expected set of metrics and flows that you might see as the demands change into this, and even as requests flow through service to service or container to container within the application. Once that's done, you deploy that, and now you start observing it. It's essentially you're saying, hey, is this the expected state? And that deviation starts telling us when there is an emerging problem. No thresholds needed, no need to decide which metrics or aspects to look at to detect an early problem. Now, the other thing we are doing, besides using this automated detection mechanism, is we are doing what's called live trace. Again, using flows like eBPF, which sits on the kernel, we can look at request to request between containers and services at the L4, bytes and packets level, as well as request URL level. that gives us, in some sense, the added golden signal, because typically you want request rates, response times, and error rates. So that gives that as life at an aggregated level. And that's very valuable to detect problems and understand what is happening across the application, not at a single service, and provide that benefit and that visibility, in-depth visibility in real time to the ops. So this live trace using flow is important. Now, combining all of this, we do what we call our fishbone root cause analysis, which is when we see a problem detecting, we can look at the dependency and pull together. Let's say if something slows down at the ingress level, which are the services involved and which ones are causing problems, whether they are based on the ML from the behavior profiling or there's a Kubernetes alert, etc. So we can narrow down the area and even down to the trace you want to look at. Just doing these three things, automated detection, providing them the live trace view, the dependency map, and fishbone, cuts down on the amount of time that ops needs to solve the problem. And then, of course, you can now design run books, or what we call using the operator concept. This one we haven't worked on. But that, in a nutshell, collecting the data from the open source, organizing it to understand the dependency, figuring out what the expected behavior is, what we call baselining using ML, and detecting those problems and doing causal analysis is what we want to do, sitting on top of that open observability platform. So what does that mean? We can, without doing any custom telemetry, any agents in the host, in the containers, or even using any need for sidecars or code instrumentation, we can start detecting application slowdowns, error rates, apps configurations, problem service calls, etc. And you can expand that. The whole idea, as we said, as you can see from this list, I'm not going to go through everything, give the ops teams the right information to focus on to solve the problem to resolution. That's key, because without that, we are facing that problem that we talked about: scale, dependency, complexity, and dynamism that just can't throw people at it. So we want to automate as much of the process as we can. And our contention is, and what we've proven is, you can do that by building the smart layer on top of that, all the set of open telemetry that's there. So the first question you probably want to ask is, well, then how do you deploy? And this is where it becomes easy for us. We don't want to touch the application, whether it's running in a VM or in cloud or in the Kubernetes cluster. As you can see, is, let's say the greens are the application pods you've installed, as you can imagine, Prometheus, the advisor on them, node exporter, Promtail for logs, and Jaeger Prometheus. We just sit in a single pod per cluster in this monitoring plane to cloud information from the cloud for infrastructure services, a Jaeger gateway to collect Jaeger open tracing. Sorry, just went to the wrong one. Sorry, I just switched tabs. Prometheus, logs, and Kubernetes. So by just collecting those 5 sets of information, one pod per cluster, sitting on the monitoring plane, we can pull all the information we need, and then we compress and, of course, send it to our apps controller. Sorry, keeps jumping back to the chart here. So that's the deployment we need. So as an example, before you get into demo and show you a little bit more, here's an example of what we can solve, in case I don't need to have time to cover everything in the demo. So imagine a response time slowing down at the ingress level. You can detect this using flow metrics right at the ingress. And then the question is, how does that propagate across, and which path did that request take that caused this problem? Using the way we just talked about it, we can actually figure out the longest latency path across from the ingress, across the application, and pull that up. Once we do that, we can analyze the anomalies on the path and then tie it to the situation here. For example, in this path right now, it's showing a simple one, which about, as you can see from the ingress, there is 1, 2, 3, 4, 5 containers, ends up in talking to a database service. In this case, happens to be AWS RDS. And we have detected increase. The system also detected there was a machine learning alert because something unusual happened in this cache server. And there was also a similar alert on this database server. So it pulled all of those, looked at which are the contributing, so that now the ops team can look at this path. Of course, even pull up traces now on this path if they need to, and avoid, let's say, another 30, 40, 50, could be 100 of the paths they have to look at. So you narrowed the space and you told them which ones to look at. So you're leveraging the information from not only the real-time dependency, detecting it, pulling in and associating alerts that are predictive, even though you didn't set a thresholds, possibly even pulling in things like other Kubernetes alerts, right? What's the advantage here? You're not relying on people to understand and know the application, because they're not necessarily the dev team. You don't have to go in a war room and people bring all these people, each one trying to decide what to look at. You didn't have to do proprietary code instrumentation, and you didn't have to go through some, correlation, mappings, looking through logs and everything else. You can still pull in logs, but now you can confirm it by looking at this. That makes a huge difference in the time to detect and resolve. Here's a simple one. This actually is being taken from a customer production. That's why they've been blanked on. This is not obvious, but what happened here is there was a volume mount failure. And what we are showing here is part of what we call our fishbone that says, oh, there was a startup failure. And the reason this application didn't come up is because it could not get the data on the persistent because the volume did not mount. Oh, the volume didn't mount because you didn't have the right key to use it. So going straight to the cause by looking at the overall application and the dependency, you've just reduced the time to do that, right? So that's an example of that. So in general, what we want to do and why we want to kind of build on that, what we are doing essentially, as we said, to summarize, behavior profiling, getting specific and understanding how Kubernetes plays it, so we can provide deep troubleshooting capabilities contextually, automate as much of the causal analysis as possible, and then make this non-intrusive. Don't need to have code changes or custom agents. And as we said, the reason is we are built on open source foundation, CNCF, and open source software. If you're not building on threshold-based alerts, you've reduced the amount of alerts you're managing, you've reduced the time to resolve, and of course that means you can be more agile, etc. Right? So, and I've already talked about this, improves your SLOs, reduces time. You can also optimize on the amount of resources you're spending. So that's kind of a quick summary. I wanted to give you an example of a root cause analysis, but instead of playing the recorded demo, what I'm going to try to do is switch over and find the live demo, and may the gods be with us. And I'm going to jump on the screen that is actually running on AWS. So let's see if this shared screen is working again. So what I'm logging in, if hopefully you can see it, can someone give me a thumbs up?
Yeah, I see it.
All right. So this is our landing screen. This is a landing spot of what we call our app map. And that app map is that dependency. If I zoom in and zoom out, what you can see is, for example, requests coming in. You can look at all the flows of who's talking to whom. Like this is talking to the Jaeger, this is around the collection. Maybe I'll switch over to the application side. So this is part of a shopping app, for example. So if I look at, for example, shipping service as an example, you can actually see what it's talking to. This is the service, right? You can see you can add SLOs, SLIs. You have full details on what's being collected, detailed views. I'm not going to go custom labels, all pulled from the Kubernetes side, Kubernetes configuration that gateway pulls. If I go to a specific container that behind that service, you can see similarly there, but I can also put in metrics, events, logs, connections, and traces. Let me just start with the connections. Remember, this is the depend. If I go to connections, it actually tells you who's talking to whom in and out of this. Now, there's another thing that you can see. You can actually see as I hover on this, it actually gives you real time, the aggregated response time on that port. So you have that visibility built in because we are leveraging and combining flows. So L4 metrics besides the metrics underneath. So you have the full structure and you're looking at how much data is flowing through that. That's kind of cool because you don't have to guess, even as the configuration changes or you make changes to the app. And I know that it's the shipping service source is talking to Jaeger. It's also talking to the front end server. You can see this is outbound. Similarly, it's also outbound talking to the checkout service and what's coming. So you're looking at that whole structured dependency, so you don't have to guess. You don't have to rely on trace to figure this out. All happening without anything. And of course, I can look at average latency, etc. Right? So what else? I mean, another thing is, okay, if this is running, what exactly is it doing? One of the things you can look at is, of course, I can obviously go to the metrics. I can pull everything in. So it's contextually integrating the flows, connection metrics. I have all that tied in contextually within the context of the application. You have a real-time view of what's happening in the application. That's the first thing you need to know. Instead of guessing and looking at, a trace or some proprietary host agent, this map without relying on anything like trace, which is what most people do. Of course, I can go to traces. So let's do that. I can now pull in the trace across that application, give it a little bit of time. Hopefully, I don't have traces on this one. So I better go, maybe I'll look at a trace map, depending on which one's being actually collected. So I'll go to a trace map. I can see from the front end of that application. And here's an example. The ones that are being traced is from the front end to checkout service, to product, etc. And it gives me all the common trace paths. And there's a whole bunch of these. So I've kind of connected from the application in the trace map. I can take any one of these and says, can you show me what that looks like? And I can go up, dig into that, say, oh, okay, so this is some of the common traces. Can I look at any one of these front end and look at the trace along that? And now I can pull in, and this will look familiar even the UI is changing. It should pull in the actual flame graph of the trace, and there it is. So I can take any one of the front end and say, okay, what is the trace running on? This has 18 spans, and there you are. You can start looking at that point. So you're going from looking at flows across the app, picking a common trace path, as I said, and going down to this. All right, so that gives you how contextually we can integrate all of this back and why it allows you. I'm going to close this window here. See if I can find my screen. Okay, so going back to that app map here, if I can go back, and go back to that app map that I had before. So there we are. We were here somewhere. Another thing that happens when we're looking at this is, remember, it's the dependency. So if I want to look at the dependency, I want to see, how does this, where does these services sit on top in corresponding to the node clusters? So one of the things we do automatically is build together, fingers crossed this loads fast enough. There is a 5-node cluster. And what you're seeing here, and you can see 1, 2, 3. Let me just get this find. Oops, wrong way. Grab this. These are the 5 Kubernetes nodes. Kubernetes host nodes. I can take any one of these and start seeing what is running in each of these nodes. So if I take one, let me just close this. You can see, for example, here, this is relatively lightly loaded. Let's pick another one. Oops. Not doing a good job navigating through this. This one is 10% CPU. Okay, you can see all the containers that's running in it. So you have a full picture. Not only that, you can, of course, look at the metrics config. I won't go, that will take too much time. So in the interest of time, I'll show you what's an interesting thing that happens in terms of use of resources. How much resources are being used by every service running on the container? Because one of the biggest things that people have is, hey, who's using most of the CPU? Who's hogging and who's using most? So if I look at, hey, current value and let's say average, let's say 1-day average. If I look at that, okay, I see Cassandra running on Helm is using this. Its current value, current value is 333. It's best effort. The max is this. If it's best effort, it might get, evicted. But on the other hand, if I pick something like this, I've given a limit of 300. This Helm Loki, 300, but it's only using 32. It's highly over provisioned. So you could start seeing, in order for the applications to run, what we can do. It's another view that you need beyond just performance. So going back to the app map, the question then is, how do I know when there's a problem, right? So I'm going to switch screens and look at what's called the alert screen. On the alert screen, what we do automatically, and I'll just click on this. Let's pick an alert. So what is happening is, without setting thresholds, and after the system has learned about these profiles of the application across this, all the services across the application, it automatically detects problems, whether it's an SLO breach, and let's look for one. So let's see if I can pick one that I am familiar with, that I know has an interesting one. 5435. I think this might be interesting. This says response time SLO breach has happened on the injects. It happened this morning. Oh, actually about a day ago, but that's okay. So you'll see in this case, it detected again using flows, not requiring any kind of traces. It says, hey, the response time, 15 seconds, was much higher than our average expected 2.5. Here's where some interesting things happen. Now, I want to point out that obviously I have a lot of the history. I'm not going to go into that. There's an analyze tab, and this is essentially doing that root cause analysis, especially on service level objective. It does what we call analysis of the path. So what you're seeing is it analyzed the paths on where it was and picked the path that had a problem. So if I hover on this, let's see if I can get more detail on this. So 15.4 seconds here, Nginx goes to that, and it points that there were 2 or 3 other alerts on that path. And obviously you can see below cart cache, which is this one, had a higher than expected response time, which contributed to this larger one. And there were some other alerts here. The question is, what caused this SLO to breach? And so you can go down here. If you click on it, this is pulling up an individual ML-based fishbone that says, why is this high? It actually shows things like the demand response time increased. Again, can I get this? Looks like it's not being very cooperative. I'm sorry. It's not pulling the data that I'm looking for. Slow. But I'll just go ahead. It's basically amount of time it's taking on the demand side, meaning its response time is high. CPU is also high. I wish I could get this to load. It's not loading as well as I thought it would. So that's one. Oops, I jumped out of that. Let me see if I can go back to it. Live demo, guys. So give me a little time here. So we found that problem, right? So we know that is one. So that increased. Oh, I'm keep going back to the wrong one. 539545. This is what it was. All right. There's another one. Cart server has a problem, and guess what? It says there is no pod behind the service, and we are wondering why is that. Go back again. If I find there is supposed to be a pod behind there, and cart server, this had higher response times. This also has a problem that says no pod. Why is there no pod on there? It said, oh, the container is not running. Why is it not running? And let's go back again and look at it again. And I look at, there's a pod here, and I go look, it actually done an analysis on that. It says, oh, back off restart, which means it's trying to basically restart, not doing this. And if you click on it, it says, oh, back off restart, and there's an issue with the image name. Is this voicing that's what's causing the problem? But it's because of the back off restart, it's not loading that image, which caused the problem of, oops, the wrong screen again. If I go back to this part, not navigating fast. So if this image, this pod did not load because of the backup restart, this doesn't find the pod, this doesn't find the pod, cart cache increases, which increases the latency. So net, and I want to kind of wrap this up because I want to give an example, trying to tie all this. The whole idea is, instead of the ops team trying to figure out when you detect a problem, trying to look at traces or thresholds, find when there is a service level breach, find what caused it, find the actual path. I didn't pull in the trace here. Bring all those together. In this case, there was a service level breach on the application. There was an increase in one of the containers. And then from Kubernetes, we found one of the services did not load and was doing a backup restart. So the whole idea behind this, again, as we pointed out, is try to make the life of the user easier, the ops team user, so they can solve this problem without relying on this. So this is kind of similar to that. So again, leveraging on that smart layer of pulling in information at, doing the view of show me where the problem is, detect it first, show me where the problem is predictively, and leverage that information, the dependency mapping, and run this causal analysis so I can get to the right place, so I can fix this. In this case, if I knew that part was not going, find out why it wasn't loading. If I can do that, that delay will go down on that path, and that would improve the SLO on the service, on the application. So I'm pretty much at the end of kind of the overall demo, a part of this. And so what I want to do is, if there are questions, Cheryl, I don't know what the structure is. We'd love to take questions if we can do live and cover, what people have to ask, and if there are any questions I can address.
Absolutely. Thank you so much, Aloke. I'm going to take over sharing your screen.
Please do. I'll stop sharing.
As before, if you have any questions, then you can go to this link on your phone or on your laptop and submit them here. This is like a Reddit style question, so there will also be like up and down thumbs voting. Yeah, we'll just wait and see if there are any questions from the audience. But yeah, really, really good demo. Thank you for sort of taking us through all the different scenarios as well.
Oh, we got about 80% loading, not everything, but that's what happens.
It's a pretty good, demo gods, 80%, that's pretty good.
You'll take it, yeah. So hopefully, that made sense to people. And again, the whole idea is you can build observability that actually helps you right on open source foundation.
I like the open source foundation, of course.
There is no reason not to. There's more reason now to.
It's definitely been interesting seeing that transition from mostly proprietary pieces to mostly even open source. Yeah,
I did not mention the other trend that we've been seeing even at most recent KubeCon. That was in LA. And then I'm seeing and hearing at the DevOps meetups I go to, which is open telemetry. Open telemetry is no longer just about open tracing. It pulls in all the open source collection of telemetry, including metrics like from Prometheus, logs from Fluentd, however you want to manage it, Kubernetes, of course, and now tracing. So again, across the board, all of the tracing and all of the aspects of telemetry that we talked about in that response is available.
The trend that you're seeing is more people are using open telemetry, and
now becoming, as they're getting more and more cloud native, realizing that doing proprietary host agents or proprietary core instrumentation doesn't necessarily solve the problem, but also when they have to embrace others, they have to undo those and rely on it. And because things like host you have to touch, if you're trying to do many of these things, it actually slows you down in the deployment. Our deployments, because you install these open literally with a Helm chart, 5 to 10 minutes to deploy. And probably within less than 30 minutes, that whole app map, the dependency that I talked about, shows up. So not only is it faster, it also essentially gives you all the telemetry you need. Then the question is, how can you leverage that? And that's the part where we are now throwing people at it. And our job to be good stewards of observability is to reduce the amount of data you're looking at, because clearly it's kind of just gets out of hand.
Yeah, that's for sure. Yeah. Looks like we're not seeing any questions for the moment, but if people have questions afterwards when they're watching this, then Aloke, what's the best way to get in touch with you?
Yes, I'm going to type this in. Please reach me. It's easy. At Aloke, it's easy enough. OpsCruise opscruise.com, or just ask for info@opscruise.com. As I said, there are, if you just remember cruise control for operations, that's OpsCruise. That's what we want. Just set info at or Aloke, my first name, at OpsCruise.
All right. Thank you so much, Aloke. Fantastic talk. Really, really, yeah, just enjoyed seeing the broadness and the coverage of like lots of different ideas and how they come together. So thank you so much.
Yep, and look forward. Maybe one day we'll meet you guys in London, and I'll actually leverage my British passport. Thank you again for inviting me. Tom and David, nice to meet you, and maybe one of these days we might meet in person. Till then.
I hope so. As said, we are back in person from June, so hopefully I will see some folks coming from June onwards. That's it for tonight's meetup. If you want to speak or to sponsor, then go to cloudnativelund.com, where you can request a speaking slot, or you can sponsor these events, or you can promote your own events as well. And that's it from us this evening.
Thank you very much. Have a great evening.
Tom, David, see you later.
Bye.